Thank you for the invitation and good morning to all people here. I will present one of the many crop models. This is very recent. We developed in our department. I am a physicist, so my background is a little bit different from the background of many people here. But we were involved in the last 10 years in this project about vineyards. So we decided to develop this new crop model. I will describe shortly the crop model, and I will prefer to dedicate more time to the validation of the model and to the result of a long-term run in our region, which is Piedmont, the same of which Federico talked, and some conclusion we can do about this model. The first question to say is why to develop a new crop model? There is so many which we can use about vineyards, and of course Antonello and Federico already talked about why it's important to develop a crop model, so to study locally the physiological and phenological condition of the plants, and to help the farmer in the production, in the cultivation, in order to optimize, the strategies to improve the quality of the final product, which is the wine, and also eventually to do some adaptation countermeasure in order to combat the climate change. So this is why it's important to use crop model. I did not answer yet why we decided to develop a new crop model. And the reason is that we were involved in a project with some specific questions, and to answer to these questions, looking at the available crop model, we could not find one single model able to answer all the questions. So we decided to collect information from existing crop model and to try to transform some parameterization in a physical way. And then also we changed the language, because in meteorology, which is my background, we use a Fortran language, so we developed a model in Fortran language. This is the model. IVINE means Italian Vineyard Integrated Numerical Model for Estimating Physiological Values. Actually, I should have had also phenological values. We need some data, which is not easy to get from vineyards. So, for instance, all this data we need at least at an hourly basis, especially air temperature and the relative humidity, but we need also solar radiation, photosynthetic active radiation, soil variable, soil temperature and soil moisture, wind speed, direction, rainfall, and leaf wetness. These last three data very useful for evapotranspiration calculation and for disease. Actually, we did not develop the disease part in our model. This is a future plan. We need also some data from the location, data regarding soil. The best way to use the model is to use measure from the soil, which is not easy for any vineyard. So sometimes we use the soil texture, which has been criticized by Antonello correctly. So, of course, if available, it's much better to use a local measure, because in this way we can characterize much better the transfer of water in the soil. We need information about the plant density, so how is built the vineyard, and some other characteristic about the variety and the management. For instance, we need to know when the farmer do some operation about the vineyards. Then the model can calculate mostly these quantities, the predown leaf water potential, the development of leaves, so leaf area index, the sugar concentration, the phenological phase, some physiological phase, and the yield. This is the paper we just published a few months ago in February. So you can consult this paper about the model. And I have no time now to explain in detail the equation of the model, of course. I have just 20 minutes. So I will just give some general ideas about soil texture. We consider mostly the quantity of sand, clay, and silt, and we use the standard soil texture classes. This is the other information about the vineyard. So how many soil layers we consider in the model? Usually we consider 3 or 4, but this quantity can be chosen by the user. And regarding management strategies, we consider trimming and thinning. Okay, so of course, we need to validate the model. This is the most important part, because to develop a model is very easy, but then you need to check that the model is working well. But it's difficult, because we need to find a long-term series of data to check the model, eventually also to calibrate the parameterization. So I did not mention that for the moment, the only variety in which we calibrate the model is the Nebbiolo variety. Nebbiolo is very famous in Piemonte because very famous wine in Italy are made by Nebbiolo. So actually we added some other variety, but the paper is just mentioning Nebbiolo. Okay, I already passed to show you some result. This is one vineyard. I show you just 2 years. We have several years, but this is the Julian day. So 150 means approximately May, and 290 means near October. So this is the vegetation period, and this is measurement, and the curve is the simulation, and the variable is berry weight. 2 different years, 2007, 2005, with 2 different meteorology. So, for instance, you can see that the final value is similar, but in 2007, the final value was reached much early than in 2005. So anyway, the model made some overestimation in 2007 and some underestimation in 2005, but the difference is about 0.2, 0.3 gram per plant. This is another variable which is very important, because this is the sugar content, and this variable can influence the alcohol content of the wine. So it is important to predict very well. Also, if you want to make some study about the climate change effect, because climate change can change the concentration of sugar. So in this case, the model uses the double sigmoid parameterization, and you can see that the model seems able to capture very well the cycle of the sugar in the plant and also the final value. Same site in the center of Piedmont in Langhe region, and 2 different years. Also in this case, 2 different years, quite different meteorological. This is a little bit more difficult to read because it's a table comparing simulation and observation of phenological phase in which are printed here as a BBCH stage. And the problem is that not always the farmer was observing the same phase, the same stage simulated by the model. So sometimes the stage is different, like in this case, but the break, the simulation simulated the stage number 7, but the observation was the stage number 11. So it's different. It's not easy to compare the date. So sometimes it's better to compare when the stage is the same, like in this case, or in other case like this one. But this is the typical difficulty when the farmer is not always present in the vineyard. The farmer not always go every day to check the state of the plant. So anyway, the comparison show that the typical error in number of days is about 4 or 5 days of overestimation or underestimation. Regarding the long-term run, of course, we don't have any long-term series of meteorological observation, so we needed to use external database. We find this database GLDAS, Global Land Data Assimilation System, which contain data for 70 years of observation, gridded in the world. This is the characteristic of the database. The data can be downloaded from internet. We choose in this global database this area. This is Piedmont region. This is the area more suitable for the wine production. So this area contains 16 grid points, and we excluded these grid points because was in mountain, and we considered the other 15 grid points. This 1, 2, 3 are grid points in which we made some comparison with the data measured in vineyard. Comparison was good, so we deduced that we can use this database for this kind of simulation. This is the distribution of elevation of this point, so the maximum number of elevation is between 100 and 300 meters above sea level. And, okay, it's not reported here, but most of the soil type is loam, so it's equilibrated soil type with a similar quantity of sand, silt, and clay. This is the 60 years of simulation starting from 1950 to 2010. And these are the grid points, 15 grid points, actually a selection of 15 grid points. And you can see that for the variable fruit set, you can see that all grid points show the same trend, decreasing trend. Here you have the Julian day in which the fruit set has occurred for every year. And you can see also particular characteristics that in the first 30 years up to 1980, you have almost a stationarity, while from 1980 to 2010, you have a very clear decreasing trend, much larger. So it's like climate change has started to have influence in the last 30 years of this period. This is the sugar content. You can see again a very clear increasing trend, very similar for every grid point. And also in this case, you can see a division up to 1980. You have a stationarity with a very large variability between several years, while after 1980, you have a clear increasing trend with a much lower variability. So this is a clear effect of climate change. Here we selected just one point to give a representation more realistic because the trends are quite similar, and we selected several phases. For instance, this is interesting because, for instance, dormancy break is showing increasing trend to late dates. So the dormancy break start later and later, but the bud burst start early and early. That means that the sleeping time of the plant is shortening, because it's shortening from two sides, from this increasing trend and from this decreasing trend. That can have not a good effect about the quality of the production in the next year. I am not an expert about this question, but I read several papers mentioning this problem that can be more severe in the future because the trend is continuing to increase and here is continuing to decrease. In terms of variation, you have about 8 days of delay in the dormancy break and 15 days for the other phase. Other phase, beginning of ripening, veraison, and harvest. Decreasing trend, about 12 days. For veraison, decreasing trend about 25 days, like 1 month. Harvest is interesting. The model is tuned about the current practice to product Nebbiolo wine. But there is a limit of the model. So the model can predict the phase of harvest when a certain level of sugar content has been reached. When you see this line of continuous, constant harvest time, means that the model never reached that threshold of sugar. That means that in the past, producers made Nebbiolo with different techniques, not like now. This is obvious, of course, and I personally don't know which were the level used by producers in 1950. I have no idea, I was not born yet. But anyway, that means that this is an effect of climate change. Maybe for the future we need to change again the producing technique. This is leaf area index. This is again a decreasing trend, and the months in which a maximum leaf area index shifted from October here to September to August. So that means the maximum development of leaves. Sugar content, again, increasing trend. And here, this is interesting, maybe you can answer in a different way to the question you posed about elevation factor. These are 3 different elevations, 269 meters, 400 and 600 meters. And this is a bud break, for instance. And you can see that if you look at the 3 different elevations, you can see that at the end of the period here, the value, for instance, of the intermediate elevation correspond to the value of the lower elevation at the beginning of the period. So in these 60 years, but actually in the last 30 years, we have lost 200 meters of elevation. The climate change is corresponding to an increase of elevation of about 200 meters. You can find this in the bud break Also in the flowering, this is even more evident. You can see this is the highest elevation, 600 meters, and if you continue, you can arrive to the medium elevation, so again 200 meters. While this is effect of two type of soil texture is not so big effect, actually in our model. This is a berry sugar content. You can see so large increasing trend. And this is leaf array index. The leaf array index, for instance, is showing recently a very small interannual variability. So every year you have more or less a similar value to the previous year, while in the beginning of the period you had some bigger variation between one year and another year. Same for the production. So the number of gram per plant is increasing. So in conclusion, I presented very rapidly because time is running, our model and especially the application. I think that this kind of model, not only our, but generally crop model, can be very useful to evidence the climate change, but you of course need to calibrate very well the model. So for instance, at the moment, we use it only for Nebbiolo vineyard. We are already added some parameterization for other cultivars used in our region. Our plan is to parameterize every variety in the world, but this requires some data, which are not easy to get, because we need not just 1 year of observation, but some years, because 1 year can be very specific from a meteorological point of view. So we need 4 or 5 years of continuous observation in order to calibrate the model in several different conditions. Anyway, if we can do this, this kind of model, in our opinion, is very useful to evidentiate some trends. And of course, the model can be made more complex. This is our first version of the model. We are planning to complicate the model by adding some new parameterization for other variables, for instance, the disease or alcohol content, anthocyane, and so on. Okay, thank you.
Thank you, Claudio. There is a question from the...
Oh, go. Okay, no, just a clarification, because I was called into discussion by you. When I have stressed the question about soil, is due to the fact that in your system is the only part that you correctly can describe in terms of physical law. And what happened that when you try to calibrate a model without a good description on soil, what you do for a calibration, you force other parameters on crops and arrive to describe the system in an incorrect way, for which under different boundary condition, your model go to another direction of reality. And I have seen something that could be due to this on your first figures on berry grow, in which your model was probably not sensitive to the boundary condition. The grapes go in a sinusoidal model, your model go in a direction that clearly, in my experience and modeling calibration, it could be really due to the fact that this part of your system is not correctly described, then is not able to make an effect on your final function, that is the berry. And for this reason, I stress we have to look to this, because to the soil, because it's a very important part. And after you don't see, your model become not sensitive to the environmental condition. It's just for this, not because I'm a pedologist, but it is real. Okay.
Oh,
it's just a clarification.
I accept this observation, because we also We also know that our model has a very good point for some calculation like berry sugar content and some weak point for some phenological phase and the berry weight, which we need to improve. However, still with these uncertainties, the level of the result we get is similar to the result published by other people in literature, but we need to improve. We will try to do as soon as possible.
No, I understand that. Surely if you use some statistical index to evaluate your model, like RMSE, root mean square error, it works good because it is not distant the measured by and simulated, but if you use other index like efficiency index or etc. that try to describe the behavior, your model don't fit really good. And surely, I don't know your model in terms of sub model, but probably the part on sugar is based on other information that comes not from the soil-water balance, probably more related to temperature or other part that is more strong compared to the other part of model.
Anyway, we can also collaborate.
No, it's just to stress why, because I talk about soil, not just...
Sure. Thank you.
Please, Joao.
Good morning, thank you very much, and congratulations for developing this new model. My question is just if you have already compared your model with, for example, sticks or other models that are currently available.
Yeah, we didn't compare exactly on the same place because we are unable to run a stick by ourselves, but 60% of parameterization of our model are based on sticks parameterization.
Okay.
And
so we should expect some similarities because some parameterizations are the same.
Actually, just similar, we changed some coefficient because we adapted coefficient for our region. Stick was based in France. France is very close to Piemonte region, but anyway, climate is different. So we shared the similar parameterization, and we looked about publication of sticks on vineyard. And in this sense, in the paper, we compared the result of papers of sticks and other models. And our model was in the middle of the result of other. So in this sense, we think that the results are comparable with our other model. The improvement that we can have with our model is to calculate all these quantities together with just one model, which is not the case of several other.
Okay. In the Clim4Vitis project, we will have data sets from the fields. Maybe we can try to calibrate the model for your model for other conditions, for example, in Portugal and in other places.
For this it will be very interesting for us. We are hungry to get some observation.
So thank you for your talk. So first, I don't have any background in, let's say, wine science. I'm a computer scientist, a background in data science. Can you come back to your slides when you show all those linear regression across time? You have, I don't know, a dozen of charts. Like this one, I think it's this one. Oh, yeah, this one. Okay. You said that apparently there's a change before the ITs and after the ITs.
Yeah.
And which is more or less obvious on the charts. And did you try to simply split your data set in two parts? It looks like before the 80s, it's difficult to claim that there's a linear regression, but after the 80s, it's quite obvious. Yeah. So perhaps your model could be much better after the 80s, where the linear regression, I would say that statistical correlation is for sure better after the 80s than before the 80s, which is more,
I think before the 80s, for some points, like for instance, this one, there is no any correlation, at least statistically significant. After the 80s, I think every grid point has a statistically significant correlation.
The 60, there was a short cooling period, and that is detected by.
Sometimes, yes, like here it seems, but
so
it's very sparse.
Purely from a data analytics point of view, only independently of the meaning, perhaps either to use a nonlinear regression or to split the data set, and especially for the more recent part, possibly you might have much better prediction simply because the data shows that there's a change in a phenomenon which you cannot cover with one single linear regression only. That's just,
Okay, thank you.
Another question, please. Giovanni.
Hi, I'm Giovanni Cappelli from CREA of Bologna, and I would like to know how many parameters the model has, and if you have considered using sensitivity analysis before calibrating the model in order to establish which are the parameters which has a higher influence in determining the output of the model.
Yes, the number of parameters is about 10, and many of them are for the thermal sum we use for the phenological phase. We did the sensitivity analysis. For reason of time, I did not show the result. The two most important parameters are temperature and soil water potential, or soil moisture anyway. Temperature is entering practically in any equation of the model. Every parameter is based on temperature. Many parameters are based on soil moisture, like evapotranspiration and others. So the sensitivity to temperature is, of course, very high and is mostly linear, excepting that for some variable like sugar concentration. And the sensitivity to live water potential is also large for some parameter.
Because I think that maybe this would be helpful in light, in the view of calibrating the model and apply the model to other varieties. It would be interesting.
Yeah. Actually, in the paper, we included the sensitivity in the published paper.
Thank you so much.
I have other questions, but we should cut because we have short delay for the coffee break. So please. Thank you.